All right, students, today we're going to be talking about chapter 3 in the textbook, which is the measures of central tendency chapter. All right, so let's talk about measures of central tendency, what they are, and what their use are. Okay. So a measure of central tendency, the just plain textbook definition of a measure of central tendency is they are either numbers or a number that describes what is average or what is typical of a distribution. Now, before we proceed on, I think it's also important that we understand what a distribution is, because last chapter we talked about frequency distributions, but the term distribution is a term we're going to be using throughout the rest of the class. Okay, so it's important for us to understand what a distribution is when I throw that word out there, or you see it in the textbook, or you see it on the homework, or you see it on the exam. You want to know what a distribution is. Okay, so a distribution, simply put, it tells you how people fit into each category of a variable. So to elaborate on that a little bit, the example I believe I used last chapter, we were talking about distribution of sex in a class. Okay? So let's just say that we have the variable sex. And then we know that we have females and then we have males. And let's just say that we have a frequency distribution up here, that we have 15 females in the class and then 10 males in the class, okay? So what we have here is the distribution of sex, or it tells us how the variable sex is distributed in the class, okay? So that's essentially what a distribution is. We can do this with any variable that we have. I know we can have religion up there. We can see how many people are Christians, how many people are Catholics, how many people are Buddhists and atheists. We could, I don't know, put up, pet. How many people have dogs, how many people have cats, people have lizards and snakes and so on and so forth. So that's essentially what a distribution is, or, how many, if you look at race, how many people are black, how many people are Latino, how many people are, white, how many people are Asian, how many people are Native American in the class. So that's essentially what a distribution is, okay? And a measure of central tendency, what that does is it tells us, it gives us a number which describes what is either average of the distribution that we're looking at or what is typical of the distribution that we're looking at, okay? So in this chapter, we're going to be talking about 3 measures of central tendency: mean, median, and mode, how to calculate them, and how you can use which measures of central tendency for which type of data. And what I mean by which type of data or which type of variable, we're returning back to the whole concept of nominal, ordinal, or interval ratio. Okay, so let's talk about the first one, which is the mode. Okay, now the mode is the category or score with the largest frequency or percentage in the distribution. Okay, if it's the largest frequency, it's also going to be the largest percentage in the distribution. Okay, so now the mode is the easiest to find, and I really don't intend to spend a lot of time on this because it's just easy. Okay, you simply locate the category represented by the highest frequency, or you look for the biggest number. Okay, so that's relatively easy to find. So for example, if we revert back to this distribution here, we see that there are 15 females and 10 males. So which category is the modal category? Females, because there's more females than males. And that's pretty much how you go about finding the mode. Like I said, there's really not much to elaborate on beyond that. So the mode is used to determine what the most common category is. For example, we're thinking about what's the most common foreign language spoken in the US. We can look at this distribution. We can see that Spanish is by far the most common language, foreign language spoken in the United States, with 17,339,000 approximately Spanish speakers in the United States. Now, one thing that's important about the mode, one thing that you want to know is that the mode is the only measure of central tendency that you can use with nominal level data. Okay, so if you have nominal level data, you can calculate the mode, and you can only calculate the mode, so that actually makes that relatively simple. Okay, so if you have nominal level data, don't worry about calculating the median, don't worry about calculating the mean, you can't do it. okay? You can't find the mean sex. You can't add the women to the men and then come up with some, you know, male female hybrid or something like that, okay? It doesn't really make sense. Just like you can't add the Christians, if you were doing this with religion, you couldn't add the Christians to the Catholics to the Hindus to the Buddhists, add them all together and divide by the total number of cases, then you'd have some weird religious mix where guys like just believes in it, guy or girl just believes in everything, okay? So again, if you have nominal level data, mode and only the mode. Okay, now it's possible that a distribution can have two modes. And then when we run into the situation, we have what we refer to as a bimodal distribution. It's theoretically possible that you can see trimodal or quadrimodal distributions as well, but those are less frequent. So what does a bimodal distribution look like? It looks like this, okay? So let's just say that a researcher was doing a poll, and then, you know, one of the questions on the poll, one of the statements on the poll was, America is a better country than most other countries. And then the possible responses are strongly agree, neither agree nor disagree, and then strongly disagree, and then an equal amount of people said strongly agree, and then both of those were the mode. So 40% of the distribution said strongly agree, 40% of the distribution said agree. Then you would have there a bimodal distribution, okay? Like I said, you could theoretically have trimodal or quadrimodal distributions as well. Now, this is another, so what we've been doing is we've been looking at frequency distributions to determine the mode, but you could also just determine the mode with just a list of raw scores, okay? So for example, let's just say that you have, instead of having, you know, a frequency distribution, you have a list of scores where you have Democrat, Republican, Democrat, Republican, Republican, Independent, Democrat, 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 Republican, Independent, Democrat, Independent, Republican, Democrat. So here, we just asked people, who's a Democrat, wrote down, okay, this person's Democrat, who's Republican, this person raised their hand, okay, this person's a Republican, so we have a list of scores here. So what you would do in this situation is you just add them all up. So we know that there are 1, 2, 3, 4, 5, 6, 7 Democrats. So there's 7 Democrats. We could create a frequency distribution if we were doing this as well, but I'm not going to do that right now. We can just remember there's 7 Democrats. Count out how many Republicans there are. There are 1, 2, 3, 4, 5 Republicans. So Democrats are modes right now. And then we look at like how many independents there are. 1, 2, 3. There are 3 independents. So the modal category in this situation is Democrats, because there's more Democrats than there are Republicans or independents. Like I said, pretty simple to calculate the mode. I'm not going to spend too much more time on that. Now, the second measure of central tendency is the median. Okay, now the median represents the exact middle of the distribution. And the reason why you can't find the median if you have nominal level data is because there's no rank to the categories of a nominal variable. And because there's no rank, there's no middle, because there's no front, there's no back, there's no above, there's no below. And then all the categories in the middle are, again, just randomly placed there. So in order to find the median, you need at least ordinal level data or higher, okay? Because like I said, you need a logical rank to the category, okay? Now again, the median represents the exact middle of a distribution. It is the score that divides the distribution into 2 equal parts so that half of the cases are above that score and half the cases are below that score, okay? And like I said, the variable must be at least ordinal or interval ratio level data. And the way you go about finding the median, there's a couple steps. And I'm going to show you how to do it 2 different ways. I'm going to show you the first way I'm going to show you how to do it is I'm going to show you how to do it with a list of raw scores. Then I'm going to show you how to do it in a frequency distribution. Now, the way you do it in a frequency distribution and the way you do it with the list of raw scores are different. Okay. Now, if you have a list of raw scores, what are you going to do? The first thing you're going to do is you're going to take all the scores and you're going to line them out from lowest to high. I'm going to show you how to do this on the next slide, but first thing, line the scores out from lowest to high. Okay. The next thing you're going to do is you're going to take the n, which we've discussed last chapter is the total number of cases in the distribution. We take the n, we add 1 to it, okay? After we've added 1 to that n, we then divide that by 2, and then we get that score. That is not our median. What we do is when we have that number, we count over to that score, and then that score is our median. Now, this is a lot of just me talking right now, so I think it's best that we actually show how to do this. Okay. So let's just say that we have a list of scores. So we have a total of an N of 9 in this situation. So we're looking at the number of hate crimes reported in 9 most populous US states in the year 2014. Okay. So we have these 9 scores. And like I said, the first tip that we're going to do is we need to arrange the scores from lowest to high. So I'm going to start arranging the scores from lowest to high up here. We know that the first score, or the lowest score in the distribution, is 21 here at the bottom. So 21, so I'm going to put that here, 21. Then we know the second lowest score is 60. Third is 89. Fourth is 139. Fifth is 189. Sixth is 277. Seventh, 417. Eighth is 566. And then the highest score in the distribution is 1,204. Okay. So we have all 9 scores, 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of ran out of room towards the end of that, but hopefully you all understand that. Okay. Now that I have this n, which is 9, I'm going to add 1 to it. So our n, 9, plus 1 is going to give me 10. I get that 10, I'm going to divide that by 2, which is obviously going to give me 5. So 5 is what I'm looking for. Again, 5 is not our median. What we need to do is take this number 5 and count over to the 5th score, then that'll be our median. So we count over. This is the first score, 21. 1, 2, 3, 4, 5. Our median is 189. Okay, now how do I check this? Again, I should have the equal amount of scores lower than it and higher than it. Okay, so if I see 189, I have 1, 2, 3, 4 scores are below the median. 1, 2, 3, 4. 4 scores are above the median. So that's how I know that I actually have the median score. All right, so having said that, that's how you find the median. Now, it just so happened that we landed on like 5, okay, because we had an odd number as our n. So when we added 1 to it, we got an even number divided by 2. We had an odd number, so it made that just straight 5 easy. But what happens if you have like an 8? Let's just say we have an n of 8. So these are the exact same scores, except the only difference here is that we have 21 is missing. Okay. So what are we going to do here? Same process, but instead of having an n of 9, we now have an n of 8. So I'm going to remove this 21. And then our n is equal to 8 now. 8 plus 1 gives us 9. We divide 9 by 2 and we get 4.5. Now what we need to do is count over to the 4.5 score, but there is no 4.5 score. Okay, so we go 1, 2, 3, 4. Okay, we go 4. Let me see if those are the right numbers. So we removed 21. We had, oh, there was no 60 actually. So I'm just going to completely rewrite this. So we have 89 is our lowest score. We have 139. We have 189. Okay, so I just noticed that there was an actual issue with that slide. So it only had actual 7 scores up there. So I added 60 in there to actually make it 8. And then, so these are the actual right numbers. Okay, so let's go ahead and take a look at this. So what you do is you line out those scores from lowest to highest. Okay, so I have all 8 scores, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now what you do is you take that 8, you add 1 to it, and then divide by 2, and you're going to get 9 divided by 2, you're going to get 4.5. Okay, now what you need to do when you run into a situation where it doesn't land on like a solid 5 or a solid 4 is you need to take that 4.5 and you take the 4th number and then the 5th number, add them together, divide by 2. So for example, we have 1, 2, 3, 4. Okay, so this is the 4th number. This is the 5th number. There is no 4.5. So what you need to do is find the exact middle in between 189 and 277. And then that will be your median. Okay. Now, how do we find the exact middle? What you're going to do is you're going to take 189, add it to 277. So 189 plus 277 gives us 466. Now, what you're going to do is you're going to take this 466, you're going to divide it by 2, and you are going to get 233. So 233 is our median. It is the exact middle point between 189 and 277. It is the number that divides the distribution in half, where you have half the scores 1, 2, 3, 4 below, then half the scores 1, 2, 3, 4 above 233. Okay. So that's how you find the median with a list of raw scores. Okay. Now, in order to do it in a frequency distribution, the process is a little bit different. So how do you go about finding the median in a frequency distribution? Okay. So what you're going to do is you need to take the frequency distribution. Now, frequency distribution with ordinal level variables, they're already going to be, the categories are already going to be in their logical order. So that's the first thing. Now, after you have that, the second thing that you're going to want to do is you want to create a cumulative frequency and a cumulative percentage distribution. Okay. Now, we talked about how to calculate a cumulative frequency and a cumulative percentage distribution in chapter 2, right? You take the category from the, or you take the frequency from the first category, you add it to the frequency to the next, then you just keep on adding it up to the point where in the cumulative frequency you get all the whole frequencies. So what do we mean by that? So let's just say that we're looking at political views here. Okay. And we know that after the poll, there's 1,457 people who answered the poll, and then 57 said that they're extremely liberal, 168 said that they're liberal, 187 said they're slightly liberal, and so on. Okay. To create a cumulative frequency distribution, if you all remember, what you do is you take the frequency in the first category, cumulative frequency, added to the next. So 57 plus 168 gives us 225. 225 plus 187 gives us 412. 412 plus 535 gives us 947. 947 plus 213 gives us 1,160. 1,160 plus 239 gives us 1,399. And then 1,399 plus 58 gives us 1,457. So we have created a cumulative frequency distribution here. Now, as we discussed on chapter 2 as well, cumulative percentage works the exact same way. You take the cumulative percentage distribution, or you take the percentage from the first category, 3.9, add it to the next category. 11.5, 15.4, 15.4 plus 12.8, 28.3, 28.3 plus 36.7 gives us 65, 65 plus 14.6 gives us 79.6. 79.6 plus 16.4 gives us 96, and 96 plus 4 gives us 100% of the distribution. Okay, so that's how you calculate a cumulative percentage distribution. Just add the categories together. Okay, so that's the first step. Now, there's 2 ways to go about calculating the median. One way you can use the frequencies, the other way you can use the percentages. Now, the percentages are easier. It's easier to do with the percentage. But obviously you have to calculate the percentages, right? So here the percentages are just given to you, and the cumulative percentage and the cumulative frequency are given to you. But on the homework, or when you're doing this on the exam, the percentages might not be there, or the frequency, or the cumulative frequency, the cumulative percentages might not be there. So if you don't have that, then you'd have to calculate the percentages and then create a cumulative percentage distribution, which is an extra step. It's technically easier to do it with the percentages, but like I said, it's an extra step, so it might take a little bit longer. But let's show you how to do it with the frequencies. Okay, what you'd want to do, kind of like similar to what we just did, is you take the n, which is 1,457. So we know that the n is 1,457. We add 1 to it, we get 1,458. Then we divide that by 2 and we get 729. So we're looking for the 729th number. That's the number that's going to divide the distribution. Half the scores are above, half the scores are below. Now that we have the 729th number, we need to go find where 729 is in this distribution. Okay. So what we do is we look at the cumulative frequency distribution. We don't look at the frequencies, we look at the cumulative frequencies. So when we look at 729, well, 57, that's not 729, that's way too low. 225 is too low, 412 is too low as well, I guess. Okay. So it's gonna be somewhere between 412 and 947. Okay. Now, how do you decide? Are we going to use 412 or are we going to use 947? I guess the simplest way to think about this is to find where that number is in between 412 and 947 and go down. And that's going to be the median category. So moderate would be the median category where half the distribution is below, half the distribution is above. So that's one way to think about it, is to find 729 is between 412 and 947, then just go to the lower category, and then that's going to be your median. Okay. The right way to think about it, though, is to take the cumulative frequency, okay, and then think about if you have nobody in the distribution before extremely liberal, you think about this line as being 0, okay? Then when we add extremely liberal frequency, we have 57, so then this line is 57. We add the liberals, and then that gives us 225. Okay, we have people who are slightly liberal, that gives us 412. So this line represents 412. And then here, when we add 535, that gives us 947. So this line right here, this first line is 412. And this line is 947. And then 729 is going to fall somewhere here. Somewhere in between 412 and 947. Okay, so this is 0, 57, 57, 225, 225, 412, 412 to 947. So 729 falls right here in this moderate category. So the median is moderate. So that's how you go about finding the median. Now you can also find any percentage. Now, so for example, let's just say I wanted to find the 50% mark, which is the median, right? Because the median is the exact middle of the distribution, so it's 50% mark. So you can also do this with cumulative percentages. So what you'd want to do here if you're trying to find cumulative percentages, obviously add the percentages up. Now, when you're finding the median, you need to find that exact 50% mark. Okay, so same process, 0 to 3.9, 3.9 to 15.4, 15.4 to 28.3, and this line is 28.3, this line is 65. 50% is going to be somewhere here. It's going to correspond to the moderate category. So our median is moderate. Okay, so that's how you go about doing that. Now, like I said earlier, what you could also do is just look at 50% is in between 28.3 and 65. If what I just kind of explained is a little bit complex for you, 28.3 to 65, 50% is somewhere in between there. What you do is just choose the lower one. And then that lower category is the moderate. And then that is your median. Now, like I said, you can also find percentiles. Let's just say I want to find Q1. What is Q1? The first quartile. What is the first quartile? The 25th percent mark. Just like a quarter is 25 cents out of a dollar. The first quartile is the 25% mark. So how would I go about finding the first quartile here? This becomes relevant later on, especially when we talk about chapter 4. But how do we find the first quartile? Well, same thing. We're looking for the 25% mark. So ideally, you just want to go to the percentages here. And so we go to the percentages, and then we see 25%. Where would it be? It'd be somewhere in between 15.4 and 28.3. So again, using the principle that we used earlier, we just go to the lower one. And then the lower one is 28.3, which corresponds to slightly liberal. Or you can think about 0 to 3.9, 3.9 to 15.4, 15.4 to 28.3, 25% mark is somewhere in here. You can do the exact same thing for the 75th percentile. Again, you look over here, 75th percentile, or Q3, the third quartile, is going to be 75% mark. So it's going to be in between 65 and 79.6. We know that 75 is above 65, below 79.6. So we just take the lower one, and the 75th percentile is going to correspond to slightly conservative. Or you can think about this line as being 65, this line being a 79.6. So 75th percentile is going to be in a slightly conservative. Okay. All right, so let's go ahead and give that another shot. So let's just say we were trying to find the median here. We have the frequencies, cumulative frequencies, the percentages, and the cumulative percentages are already lined out for us. So what would we do here? To find the median, again, you find the middle between 50% mark. It's going to be in between 27.29, 65.71. This is a similar concept, but they're using different numbers. So you know the 50% mark is going to be above 27.9, below 65.71. So you go to the lower one, and we're going to be the moderate. Okay, that's how you do it. Or if you're looking for the 25% mark, it's going to be slightly liberal because it's going to be in between 14.36 and 27.29. You go down to the lower one, slightly liberal. For the 75% mark, 65.71 to 79.35, it's going to be slightly conservative because you know it's in between these two numbers. You go to the bottom one, and then it goes slightly conservative. So that's how you go about doing that, finding the median, 25th percentile, 75th percentile. And you'll see the use of the percentiles later on in chapter 4. Okay. All right, so let's talk about the mean. So we talked about the median. We've talked about how to calculate it with raw scores. We talked about how to calculate a frequency distribution. For the mode, we talked about how to calculate with raw scores. We talked about how to calculate it in a frequency distribution. So let's talk about how to calculate the mean. So the way you go about calculating the mean with a frequency distribution is you are going to, well, let's not do it for a frequency distribution. Let's just do it for a list of raw scores. That'll be the easiest way because everybody knows how to do that already. So let's just run through it really quick. So the mean, what is the mean? It's the mathematical average. What do? You add up all the scores in the distribution, and then you divide by the total number of scores. I'm sure you've done it a million times before, okay? Now, the mean is used to describe central tendency and interval ratio variables. I think we've discussed this already. The only level of measurement that you can use a mean with is interval ratio level data. So you can't calculate the mean for ordinal level data, and you can't calculate it for nominal level data, okay? So this is the formula, and this is some stuff that you're probably going to want to write down because you're going to see these symbols for the rest of the class, okay? So the y with the line over, or something called the y with the bar over it, that is the mean of y, okay? Now, this symbol right here that kind of looks like an E is a Greek letter referred to as sigma, okay? Now, what does sigma mean? It means sum all the scores up, so it means add everything together. Okay, so you're going to want to write down the y with a line over it, means the mean of y. Sigma means add it all up. And we already know what n is. And what is y? What is y without the bar over it? It just means a raw score. So it means an individual score. And so if it's saying take the sum of the individual scores, it means just take all those scores and add them all up together, okay? Now, the mean, as we discussed, can only be calculated for interval ratio level data. Why? Because it's the only level of measurement that actually provides numbers that can be added together and then divided. Like I said, you can't find the mean gender, you can't find the mean political affiliation, you can't find the mean religious affiliation, the mean racial group, you know. That type of stuff doesn't make sense. Look, so you can only do it with actual interval ratio level data. So let's go ahead and find the mean murder rate per 100,000 citizens. What you would do here, you just add all these scores up together, right? So what you would do, take 16.1, add it to 24.5, add it to 30, add it to 28.2, add that to 7.9, plus 7.9 again, plus 10.7, plus 26.5. Now, how many cities are there? So you need to know what the n is. 1, 2, 3, 4, 5, 6, 7, 8. And then you would divide that by 8. And then the mean that you should get here should be 20.1. So if you add all the scores up, divide by the total number of cases, which is 8, you should get 20.1. And then when you add all the scores up, the number you should get should be 160.8. Okay, now, like I said, we've all know how to calculate the mean in a list of raw scores. You've all done that a million times. I don't think there's anything that we need to talk about beyond that. Now, when data is arranged in a frequency distribution, then it gets a little bit more complex, okay? So what we want to do is we want to make sure that we're giving each score its proper weight by multiplying it by its frequency, okay? So we're gonna use this modified formula to calculate the mean if we have a frequency distribution, okay? So we're gonna use the mean of y is equal to the sum of the frequency, so we know what the frequency is, multiplied by the raw score. So you're going to take the frequency, multiply it by this raw score, and find a number. You add those numbers all together, then you're done with the numerator, and you're going to divide by the n, which is the total number of cases. Okay, so let's just say that I gave an exam. Okay, so, and there are, how many people took the exam? 3 people got 96, 5 got 86, 8 got 76, and 4 got 66. So I got 3, 8, 16, 20 people took the exam. My n is equal to 20. Let's make that clear. My n is equal to 20 because I'm looking at a frequency distribution. N is equal to 20. Oh, this is one more thing that a lot of students have a question with. How do I know if I'm looking at a frequency distribution like this? Like, how did I know that the n isn't all these numbers added together? Okay. Now, the way that you know that you're looking at a frequency distribution, you're going to see one of two things. You're going to see one, either it's going to say frequency over here. So here you see frequency, or you're going to see an F here. So if you see an F or frequency, then you know that you're looking at a frequency distribution. We don't see any F or frequency here, so we know we're not looking at a frequency distribution. Okay, so our frequencies added up, 3, 8, 16, knows that our n is equal to 20. Okay, now it's important to understand that when you're adding the scores up, you don't just add 96 plus 86 plus 76 plus 66. That's wrong. The reason why is because 3 people got 96. So it wasn't, we don't just take this 196 and add it to the 186 and add it to the 176 and add it to the 166, because 3 people got 96. So you need to give that 96 its proper weight. 5 people got 86, so you have to give that 86 its proper weight. 8 people got 76, so you have to give that 76 its proper weight. And then 4 people got 66, so you have to give that 66 its proper weight. Now, the way that you could do this is you could take those three 96s, add 96 to 96 to 96. Those 5 86s, add 86, 86, 86, 86, 86. Add those 8 76s, plus 76, 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 and so on and so forth. And then you could add the 4 66s, 66, plus 66, plus 66, plus 66, and then divide by 20. That's the long, cumbersome, tedious way to do it, but it works because what we see here is a list of raw scores. The actual way to do this is to take 96 and then multiply it by 3. So you give each score its proper weight. So when you take 96 and then multiply it by 3, you're going to get 288. So 96 times 3, which is the raw score, multiplied by its frequency, 96 times 3 gives you 288. Okay. The next one, you're going to take 86, and then you're going to multiply it by 5. Then you're going to get 430. Next one, 76, you're going to multiply it by 8, and you're going to get 608. Then you're going to get 66 times 4, and you're going to get 264. Okay, so these are the numbers that we need. We multiplied the raw score by its frequency to give it its proper weight. 288 plus 430 plus 608 plus 264. Now, what does that equation tell us to do at this point? If you remember what the equation looks like, it is for a frequency distribution. The y is equal to the sum of the frequency times the raw score divided by the n. So we've done the frequency multiplied by the raw score. Because if you look at this equation, we need to follow the order of operations. We do the multiplication first, and then we do the sum up, which is the adding. So we have multiplied the raw score by its frequency. Now we need to add these all up to get the numerator. Okay, so if we take 288 plus 430 plus 608 plus 264, we're going to get 1,590. So this all adds up to 1,590. Now we need to take that 1,590 and we need to divide it by 20. So when we divide this 1,590 by 20, we are going to get a mean which is equal to 79.5. And if you don't remember why we're dividing by 20, it's because 20 is the n, which is the total number of cases, because there's 20 people who took that first exam. So that's how you find the mean in a frequency distribution. So to find it in a list of raw score, you just add them all together, divide by 20. To find it in a frequency distribution, you multiply the raw score by its frequency to give it its proper weight, add those together, and then divide by 20. All right, now let's talk a little bit about the theory of the mean, okay? Because one thing to know how to calculate it and things like that, but obviously we have 3 measures of central tendency that you can use for integral ratio level data, and there's going to be times when the mean is not the right measure of central tendency to use, even though you have integral ratio level data. Ideally, it's the best, but sometimes it's not the best. Sometimes you prefer to use the median over the mean. Okay, let's talk about why that's the case. Okay, so the mean, unlike the mode and the median, it incorporates all the scores in the distribution. Okay, so we can kind of think about the mean as being the center of gravity of the distribution. We can think about the mean as balancing all the scores perfectly in the distribution like a seesaw. So let's just say that we're thinking about maybe age in a class, in a college classroom. So we know that the vast majority of students, the means, at least in my class, it usually is around 22. Okay, so let's just say the mean is 22. You kind of draw a seesaw. Mean is 22. What that means is you're going to have some people who are the vast majority of people. So these dots kind of represent how many people in the distribution. Vast majority of students are going to be around 22. Then you'll have, some students who are, 21, probably a little bit less, 23, a little bit less than that. Probably have some 20-year-olds, some 24-year-olds, some 19-year-olds, and maybe some 18-year-olds as well. And then likewise, you're going to have some 25-year-olds and some 26-year-olds. Okay. Okay, but obviously, the further you get away from the mean, it's typically the case you're going to see less and less observations in the distribution. Okay. Now, the mean, let's just say this is the mean, perfectly balances all these scores. So if you were to add scores to one side or the other, what's going to happen to the mean? The mean is going to shift. So if I start throwing in more people, more older people, what's going to happen is the mean is no longer going to be here at 22. It's going to have to move over. It's going to have to move over to accommodate all the scores. So it's going to maybe like shift over to 23. Okay. Likewise, if I start throwing some more younger people into the distribution, well, what's the mean going to do? It's going to shift back to accommodate these other people. Okay. If I throw way more young people in here, then again, it's going to shift to the left. Okay. Now, the reason why this is relevant is because, as you might be able to tell here, that the mean is actually sensitive to these outliers. Okay. So the mean sorry, I'm trying to pull up something right now. So the mean is sensitive to these outliers. Okay. Now, because of the fact that the mean is sensitive to these outliers, it means that you can run into a situation where if you have somebody like really, really old who stepped into the class, let's just say that we have somebody who's 90 years old. I've actually had somebody in my class who was 82. College, right? Sometimes people come back because they just want to learn new stuff. And people love statistics. That's what I found over these past couple of years. People just cannot get away from this class. People love it that much. So let's just say an 82-year-old were to come into this class. Now, it's only one person, but that one person, because there's so much leverage, right? So we go, this whiteboard is a little bit limited, but let's just say that we were way out here, and then we have this 82-year-old, okay? Now, what's going to happen is this one individual, because there's so much leverage, because this person is so far out there, it's going to shift the mean way higher than where it should be, okay? So in this situation, the mean is no longer a good representation of the distribution, okay? So that's the problem with using the mean in all cases. So if you have a distribution which is referred to as skewed, that is, you have an extreme outlier on the high side or an extreme outlier on the low side, then the mean is no longer going to be a good representation of the distribution because this mean has just been pulled way too high. Okay? It's no longer a good representation. If I tell you that the mean is 26, well, that's not really the case. I mean, that's not what's average of this distribution. What's average is probably closer to 22. We just have this one extreme outlier. Same kind of concept if you're thinking about income, right? Let's just say that we take the average income of all the students in the class, and most students are relatively young and tend to be working part-time. So let's just say the average yearly income of students is $15,000 a year. Okay. So we've added up. Some people make a little bit more, maybe 20,000, maybe 25. Some people make a little bit less, 5. 10, something like that. But then out of nowhere, Bill Gates, because people love statistics, I'm telling you, people love statistics, so Bill Gates wants to take this class. Okay? So even Bill Gates can't get away from it. Bill Gates comes into the class, and we then calculate his yearly income into this income for our students. Well, what just happened? So the average just went from $15,000 a year to $2 million a year because this one extreme outlier pulled the mean so much higher than what it should be. Okay, so that's the problem with using the mean all the time, that if you have what we refer to as skewed distributions, the mean was no longer a good representation of the distribution. The median, however, does not shift as a result of one or two extreme outliers. Okay, so if we think about how we go about calculating the median is the exact middle of the distribution. So even though we have this one person who's super old who's pulling the mean up, well, the middle of the distribution is still right around here. Okay, if this is representing income of our students, and then Bill Gates comes in, and Bill Gates' income is way out there, you know, however many 30, 40, 50 million a year he makes, his income's way out there. This is still the middle of the distribution. So even though the mean might be pulled way out there, the median is still right around here. Okay, so in that situation where we have extreme outliers on the high side or the low side, the median is going to be a better representation of the distribution. Okay, now, like I already discussed the term skewed distribution. So a distribution can be described by its general shape, which can be represented visually. A distribution can be either symmetrical or skewed, depending on whether there are a few extreme values on one end of the distribution or the other. Okay, so because we use all scores when we calculate the mean, this makes the mean sensitive to extreme outliers, as we discussed already. A shift from a higher score to a lower score can pull the mean lower, and vice versa. A shift from a lower score to a higher score can pull the mean higher. Okay, and like I said, the mean is not a suitable measure of central tendency when we have a few extreme values on one side of the distribution. Okay, so a distribution is symmetrical if the distributions at the right and left tails of the distribution are identical. So what does a symmetrical distribution look like? Well, it kind of looks like what I was originally drawing before I threw in that 82-year-old and before I threw in Bill Gates. So symmetrical distribution looks like this, where again, the vast majority of the distribution is in the middle, center of the distribution, where the mean would be typically. Then as you get away from the center, you're seeing less and less observations to the left, less and less observations to the right. Okay, that's what we refer to as a symmetrical distribution. Now, another thing about a symmetrical distribution is if we were to divide the distribution into two halves, each half will be a mirror image of the other. So if we cut this in half, left side, right side look alike, okay? In a unimodal symmetrical distribution, the mean, median, and mode are all the exact same number. Now, this is a good example of a symmetrical distribution here. Like I said, the vast majority of cases are around 3,000. As you move further away from 3,000, either above or below, you're starting to see less and less observations. As you go further above, you're seeing less, and you go further below, you're seeing less. So that's a good example of a symmetrical distribution. Now, there's also what we refer to as skewed distributions. There's positively skewed and then negatively skewed distributions. So skewed distributions have a few extreme values on one side of the distribution. Okay. Now, when the distribution has a few extremely low values, it's referred to as a negatively skewed distribution. And when the distribution has a few extremely high values, it's referred to as a positively skewed distribution. So a positively skewed distribution is going to look something like this, where again you have the vast majority of observations are around here, and then you have maybe one extreme value, one or a few extreme values on the high side. And what just happened, this is a positively skewed distribution. The mean is being pulled too high. Okay, so this is positively skewed. So the way I like to think about it is you have like a skier, and the skier is going forward down the mountain. We have like a positively skewed distribution. And obviously the exact opposite, we have negatively skewed distribution. So this is an example of a negatively skewed distribution. but the skier is going left way down, the left side of the mountain. So in this situation, again, it's the exact opposite of a positively skewed distribution, where you have a few extreme values on the low side pulling the distribution lower than where it should be. So, a good example of that is, just say, again, the majority of students in a college class are going to be around the early 20s, okay? And then every now and then somebody will bring like their child into the class because they couldn't find a babysitter. So maybe that child's like 1 or 2 years old. So that 1-year-old is pulling the mean of the class, the mean age in the class, lower than where it should be. Okay. So that's another situation where we have a skew distribution where we have like one or perhaps a few extreme outliers on the low side that's pulling the mean lower than where it should be. So like I said, when you have positively or negatively skewed distributions, the median is a better representation of the distribution than the mean. Now, how do you know mathematically if you have a positive or negatively skewed distribution? So what you would do typically is you calculate the 3 measures of central tendency, the mean, median, and mode. And if you find out that the mean is substantially higher than the median, you have a positively skewed distribution. Now, the reason why that's the case is because we have an extreme outlier on the high side pulling the mean higher than it should be. So if the mean is substantially higher than the median, we have a positively skewed distribution. If we calculate the 3 measures of central tendency and the mean is substantially lower than the median, then we know that there was an extreme value on the low side that's pulling the mean lower than where it should be. The median is going to stay about where it should be, though. So that's how you know whether or not you mathematically know whether or not you have a positively skewed, negatively skewed, or symmetrical distribution. Like I said, when you calculate the 3 measures of central tendency in a symmetrical distribution, the mean, median, and mode are all approximately the same number. So this is kind of supposed to be a negatively skewed distribution. It's kind of supposed to be what a positively skewed distribution looks like, but I don't feel like the textbook did a good job creating this slide. Probably just look at what I drew up here. That's a better representation of a positively skewed distribution. All right, so like I said, some guidelines for identifying distribution. So in unimodal distributions, when the mean, median, and mode are identical or almost identical, you know the distribution is symmetrical. Like I said, you could examine it visually, and then you could calculate it mathematically to determine whether or not symmetrical, positively, or negatively skewed. Again, when the mean is higher than the median, we have a positively skewed distribution. When the mean is lower than the median, we have a negatively skewed distribution. So again, let's talk about how it is that you identify the level of measurement for your type of data. If you have nominal level data, you can calculate the mode, and you can only calculate the mode. Simple. If you have ordinal level data, you can calculate the mode and the median. You would calculate the mode if you just want to know what's typical of the distribution, what's the most frequently occurring category. And you calculate the median if you want to know the exact middle of the distribution with ordinal level data. So the median is better than the mode if you have ordinal level data. And then if you have interval ratio level data, you can technically calculate all 3. So if you have symmetrical data, you can calculate the mode if you want to know what's just typical, what's the most common. Calculate the median if you want to know the exact middle of the distribution. And you're going to calculate the mean if you want to know the mathematical average. Okay. However, if you have a skewed distribution, you can still calculate the mean, but it's not a good representation of the distribution, and you wouldn't want to use that. And if you have a skewed distribution, then the median is going to substitute for the mean. Okay, so it's still the middle of the distribution, but it's the best measure of central tendency when you have a skewed distribution. And then obviously you would calculate the mode if you just want to know what's typical. Now, it's important to understand that when we're talking about symmetrical, positively, and negatively skewed distribution, these concepts are really only applied to interval ratio level data and interval ratio level distribution. So you would never see like a symmetrical, well, it's not that you would never see it, but it doesn't really mean anything if you're looking at a symmetrical distribution and it's nominal. It just so happened to have been that way. It doesn't tell you anything. Same thing with ordinal level data. If you have positively skewed or negatively skewed distribution, it doesn't really tell you that much. So these symmetrical, positive, and negatively skewed distributions are more for interval ratio level data. And like I said, if you have skewed data, you don't want to use mean, you want to use the median. Kind of like if you ever go looking for housing, or like a house, if you think about buying, if you're a student, probably not, because you probably don't make that much, you're probably relatively young. But let's just say that you're just really into real estate and you ever look at like the values of homes, they never really tell you the mean housing price in like an area. They always tell you the median. And the reason why is like if you take like an area like Palm Springs, for example, well, Palm Springs is kind of expensive to live there. I personally don't know why. It's really hot out here, so I don't know why real estate's so crazy out here. But Palm Springs is kind of an expensive place to live. So the median housing value, I think, is somewhere around $600,000. But the mean is actually substantially higher. Why? Because you have really, really rich, wealthy people who own homes in Palm Springs, who buy $1 million homes and then kind of just come there, a couple months out of the year. Now, if you were to put the mean housing values of, like, let's just say the Palm Springs area, then you would think that they're just astronomical, but they're actually not astronomical. It's just some people, have $10 million, $15 million homes out there. But that's, of course, not the average person who lives in Palm Springs. So again, the mean, you can use it when you have symmetrical distribution, but if you have skewed distributions, it's not a good representation of the distribution. All right, hopefully some of that stuff made sense to you all. And like I said, you'll see the application of some of these concepts later on in the class. But right now, just understand symmetrical, positively skewed, negatively skewed. You might be thinking to yourself, who cares? Or, the percentiles that we discussed, the median, the 75th percentile, 25th percentile, what's its use? You'll learn about that as we progress through the class. All right.